Hey guys, I hope you're all doing good. In this video, I wanted to give you a little bit more information about how normals are calculated. So normals are basically vectors that define direction. So let us just assume that this is an intake valve. So when the intake valve moves up and down, this is going to be its axis. Now to define this particular axis, we need to define a vector that has the same direction. Okay. So how do we determine this vector? Now, if you see here, if I zoom in into this area, and if I just draw that separately, you are going to have this particular face made up of triangles. Okay, so I'm just going to draw some triangles here. Each and every triangle has a normal direction, right? It has a normal vector. And as you can see, the direction of this normal vector and the axis of our valve are exactly the same. So at the end of the day, if I determine the normal of this particular triangle or even create an arc with the following points, then I can actually compute this direction. So how does the arc thing work? So when I select 3 points, what I can actually do is I can construct 2 vectors. So let me demonstrate that. I'm going to take up these 3 points and I'm going to draw them separately like this. The spacing between the points have been exaggerated slightly for clarity. So with 3 points I can create 2 vectors. So let us say this is vector number 1 and I'm calling it V1, and this is vector number 2. Now if I take V1 cross V2 and let us just call this vector as V3, then the direction of V3 is going to be perpendicular to V1 and V2. That is basically your cross product. So similarly, when I take these 3 points and compute the cross product, I will get a new vector that will have the same direction as the valve axis. So that is why in the videos you see me measuring the arc, because that helps me compute the center of the arc and also the arc normal. Now the center of the arc is extremely useful when we are trying to rotate the geometry. For example, let us take a look at this simple cylinder. Now, let us say that I want to rotate the cylinder about the z-axis. Alright, so when I'm going to transform, rotate, and if I have to rotate it about a particular axis, z-axis, then I need to specify the origin. Okay, so what does that mean? For example, let us say I measure this particular location. Alright, and I'm going to copy this coordinate, transform, rotate, and if I place this as the origin and if I try to rotate it by 10 degrees about the z-axis, watch what happens. Maybe I'll just put it in the top view so that you can see what's going on. Right, so our selected point is still there. So when I click apply, you can see that it is rotating about this particular point, which is bad. Sometimes we don't want that. So what I can do is I can go to measure, direction, arc normal, and I can select 3 points to measure this arc. Now remember that I'm selecting points along an arc. Okay, so make sure that you select the points carefully. The spacing between the points really doesn't matter. Okay, so if I click apply, you can see that I have an arc normal and I also have an arc center. So let us just take this arc center first. Right click, copy, and I'm going to just create a vertex in the location where I copied. So you can see that that falls exactly in the center of the cylinder, at least in the top face. So now if I go to transform, and this time if I rotate the geometry about this new point, and then if I click apply, you can see that the geometry is rotating about that particular point. And that is why the rotation center is as important as the rotation axis. So the other thing is, now let us say I put the geometry in the front view, and I'm going to rotate the entire geometry about the y-axis, say 45 degrees, something like this. So now when I try to rotate the geometry about the z-axis, it's not going to work because z-axis does not refer to the axis of the cylinder. So I need to go back, use the measure tool, arc normal, select 3 points, and get the arc normal. Okay, alternatively what I can do is I can click on triangle normal, just select one triangle, you can see that both arc and cell normals are exactly the same. So I'm just going to copy the cell normal, copy, and I'm going to transform. And this time when I rotate, I'm going to be rotating it about an arbitrary axis, and I paste the axis. We still need to calculate the rotation origin, and I can just use the location of this particular point for that. So if I click apply, I have my point, and I can use that as the rotation origin. So now when I try to rotate the model, you can see that maybe if I keep it like this, you can see that it rotates about that axis and about that point, so which is fairly neat. Similarly, I can copy this axis and go to translate, and I can paste it in directional vector. So what I'm going to do is, now I'm going to translate this cylinder along this axis, and let us say that we want to translate it by 1 mm. If I put the geometry in front view, maybe zoom out a little bit and click apply, you can see that it moves along the axis. If I change the sign of my translation amount parameter, it goes in the opposite direction. Now these two features are extremely useful when we are trying to deal with valves and when we are trying to set up motion profiles for valves. Okay, all right, I'll see you guys in the next video. Bye.